So, good morning, students. So, yesterday I have discussed a problem related to lightly loaded journal bearing. So, now I will continue one more problem. That is again on hydrodynamic lubrication. Any one of you just read the problem statement. Kumaraya, Abhilash, yes. Abhilash SV. Can you hear me, Abhilash SV? Hello. So just read the problem statement, Abhilash SV. Ramya C. Ramya C.
Yes, sir.
Read the problem statement.
Sir, problem are not visible, sir.
See, I have displayed a scanned copy there. Is it not visible to you?
Yes, sir.
Yes,
Huh?
sir. Now
Yes,
it's
sir. Yes,
visible.
sir. Visible.
Not visible to everyone.
Yes, sir. Visible.
Okay, okay. Wait a minute. Now, is it visible, the scanned copy? Ramya?
No, sir. Scanned copy are not
Hello.
visible, sir. Only folders are visible.
So I have displayed a scan copy over here. Is it visible now?
Yes, sir.
Hello. Visible now? Then fine.
Yes,
So I will
yes.
take you, uh, just read this problem statement.
Sir, question.
This one, problem number 2, a bearing used for light duty compressor. This problem. Read this problem.
Very you done the journal as a diameter of 50 and speed of the what is journal 500 rpm and pi equal to 0.001. The SCA is equal to at the temperature of 50 degrees Celsius. Determine the frictional torque on the shaft. The power loss.
Okay, thank you. So maybe the network at your place is not good. So your voice was not continuous. Okay, I'll read the problem again.
Okay, sir.
Uh, a bearing used for a light duty compressor has a load of 1000 Newton, and the journal has a diameter of 50 mm, and the L by D ratio is given, that is 1.2. The speed of the journal is 15,000 rpm, and the psi value is given, that is the 0.001. The oil used is SAE 60 at the effective temperature of 50 degrees Celsius. Determine the frictional torque on the shaft and the coefficient of friction at the given condition and the power loss. So this is the problem statement. So again, this problem is on lightly loaded journal bearing. Okay. So because the load given over here is 1000 Newton, that is 1 kilonewton. So always, if the load is less than 1000 Newton or 1 kilonewton or equal to that, so we'll consider
Hmm?
as a lightly loaded journal bearing. Okay. So they have asked you to determine the power loss. Power loss due to what? Power loss due to friction. Okay. And other details which is given in the problem is the journal is rotating at 15,000 rpm, very high speed. So look at that speed, 15,000 rpm revolutions per minute. And the diametrical clearance ratio psi is given, that is 0.001. The oil used is SAE is 60. So it's an automobile oil, heavy duty oil, SAE 60 at the effective temperature of 50 degree Celsius. Same, and determine the frictional torque on the shaft and the coefficient of friction at the given condition and the power loss. Okay. And the viscosity value of the lubricant is not mentioned over here. Okay. That is neta viscosity value is not mentioned over here. So instead, they have mentioned the grade of the oil, that is SA is 60 and it is operating temperature 50 degrees Celsius. Okay, grade of the oil and operating temperature is mentioned over here. Okay, so in the previous semester, in the design of machine elements too, we had a chapter for the lubrication and bearings. Okay, so there we have studied how to extract the viscosity value for a given lubricant whose grade is given. Okay, SA 60 and the temperature is also, it is a must. Suppose if you want to find out the viscosity of the lubricant, if they mentioned the grade of the oil, it is mandatory to mention the operating temperature, because as we are all aware that the viscosity of the lubricant varies with the temperature. Just take an example. It's an example, not the exact value. If a lubricant is having a viscosity of 40 centipoise at say 60 at 50 degrees Celsius, its value may decrease at 100 degrees Celsius. So that the lubricant may not have that viscosity at 100 degrees Celsius. Okay. So like that, viscosity value varies with the temperature. So just to refer the data handbook, this exercise we have already done during DME2 while studying the module lubrication and bearings, where we have extracted the viscosity value from the data handbook. Okay. So just repeat that exercise to find out the viscosity, neta, referring to the data handbook. And the remaining things you just list out what are all the given data. Radial load is given, that is W 1000 Newton load on the journal. The diameter of the journal is given 50 mm, and L by D ratio. It's just a ratio, it is given in the problem. So they have not given the length. Instead, they have mentioned that length is 1.2 times of the diameter. Okay, so you can calculate the length. So L is equal to 1.2 into 50, so that gives you 60 mm. Then the speed in RPES, that is N dash, you calculate, that is used for substituting this into the formula 250 RPS. And the diametrical clearance ratio, that is the psi is equal to capital C over D. Okay, so it is also given in the problem itself, it is 0.001. Then frictional torque on the shaft. Frictional torque on the shaft, because they have mentioned you to determine the power loss. In order to find out the power loss, you need a value of frictional force, okay, and the velocity at which it is running. And also they have determined you to find out frictional torque and the coefficient of friction. So first we'll find the frictional torque. Okay, uh, very simple. So just retrieve the formula from the data handbook for frictional torque. This formula we have derived in the previous class. Okay, so just make use of that frictional torque, or you can remember this. It's very easy to remember. So hardly you will get 3 to 4 formulas in this chapter, not more than that. Just you remember it. It's not a big task for you. Okay, so frictional torque is equal to pi square neta n dash ld square over psi. Just use this formula, and also see, look at this. Referring to the table 1.1, SA 60 corresponds to oil H at 50 degree has a viscosity value of 100 centipoise. This is taken from a Lingai data handbook. So the procedure is similar that in Mahadevan also. So you will get 110 centipoise, that is absolute viscosity of the given grade oil at 50 degrees Celsius. So convert that to Newton second per mm square. Just multiply this value with 10 raised to minus 9 in order to convert centipoise to Newton second per mm square. So after converting that value, we can just directly substitute this into this formula. So MT is equal to frictional torque is equal to pi square into 110 into 10 raised to minus 9 into 250, that is n dash RPS, revolutions per second, and into 60 is the length of the bearing, D is the diameter, and the psi is the diametrical clearance ratio. Calculate the torque. I'll give you just 2 minutes for this. Just substitute the value and calculate the frictional torque observed in this case. Okay. Bhargav, Bhargav, are you there? Bhargav, Shravan Kumar, Shravan Kumar, Chandan, Chandan SB. Give me the solution for this. Find out the frictional torque. Otherwise, we'll do one thing. Any one of you got the answer? Just post it in the chat box. Any one of you who got the answer for this frictional torque, post it in the chat box. If you don't want to speak, I'll see the answers now.
40712.
40712, right? Okay. So 40712 Newton millimeter is a frictional torque. Okay, so now you got the answer. 40712.12. Similarly, so find out the coefficient of friction. So again, we have a derived formula for this coefficient of friction. Mu is equal to 2 pi square into neta n dash over p into 1 over psi. And one more thing, p value is not known to us, that is the pressure. We have a formula for finding the pressure, P is equal to WLD. This we have used it in derivation also. LD is the area when a cylinder is expanded, no? So it takes the shape of the rectangle. So when journal shaft is developed, it takes the shape of the rectangle, no? That is L into D, length into diameter. That is that becomes width. So 1000 over 60 into 50. So pressure it is 0.333 megapascal Newton per mm square. So substitute that value into this equation, coefficient of friction. So you will get the coefficient of friction. That is 1.63. 1.63. And after that, find out the power loss. Power loss N is equal to F mu into U over 1000. That is in kilowatt. Power loss F mu into U over 1000. It's very simple. F, look at this. F is force, Newton. Velocity is meters per second. Newton meters per second. Newton meter is joules. Joules per second is watt. So when you divide this value by 1000, so this power loss is converted to kilowatt. Clear? So in order to find the power loss, you must know friction force value. So find out the frictional force. F mu is equal to 2 pi square n dash neta ld over psi. Again, it is a derived formula. So find out the frictional force. Just a substitution and calculation. You need a velocity for finding the power loss. So frictional force is comes to be 1628.48 Newton. See, I insist all of you to solve the problem simultaneously along with me, because the problems, just by looking at the problems you cannot learn. So simultaneously you should solve by your end. Then velocity u is equal to pi d n dash over 1000. So that is in meters per second. Put that velocity here, power loss. So you will get the power loss, that is 63.84 kilowatts. Look at that, huge power loss is taking place. 63.84 kilowatt. Why? Just look at the data. So data, from the data you can give justification. See, speed is 15,000 RPM. Very high speed. So due to that, the friction is created. The lubricant gets heated up, so that will lose the viscosity, and in turn it leads to power loss. So 63.84 kilowatt. Is there any doubt with this problem? Let me know.
No, sir.
Is there any doubt? If not, I will move ahead. Okay, I'll take one more example, and I will leave this example as an assignment for you. Okay, any one of you from your class can read this problem. Just read this problem. Any one of you? Hello. Yasir Wani,
Yes, sir.
are you
Yes,
there?
sir.
Yasir Wani,
Yes, sir.
read the problem.
Sir, it is not visible. Yeah, now, sir, it is visible.
Okay, fine.
A
Read
bearing,
this.
a bearing used for light duty compressor has a load of 1 kilonewton, and oil used is SAE 60,
Ah,
and mean effective temperature of operation is 40 degrees Celsius.
ah,
The journal has a diameter of 50 mm, and the bearing diameter is 50.05 mm. The speed of the journal is 15,000 rpm. The L by D ratio is limited to 1.2. Obtain the coefficient of friction and power loss by Petrov's analysis.
very good. Fine. So one more problem related to Petrov's equation. The Petrov's analysis means you are suggested to use Petrov's equation. That's it. Okay. Again, the journal is rotating at very high speed, 15,000 RPM, and they have given two dimension over here. One is the diameter of the shaft, that is 50 mm, and the bearing diameter. So two values are given here. One is diameter of the shaft, and the other one is bearing diameter. So look at that. If you subtract this value 50.05 with 50 mm, so you will get a clearance 0.05 mm. That is C. What is the clearance? It is the gap between the outer bearing block to the journal. Okay, so that gap is always filled with the lubricant. So clearance they have not given directly. Instead, they have given two dimensions. One is bearing block diameter, and the other one is journal. Just to subtract that value, you will get the clearance. And the oil used is SAE 60, Society of Automotive Engineers grade 60, and temperature, operating temperature is 40 degrees Celsius. So you can calculate the viscosity neta, referring to the data handbook. Okay, so the problem is as similar to the previous one. And one more thing, L by D ratio is given 1.2, obtain the coefficient of friction, power loss. So I will leave this problem as an assignment. Okay, so all of you just try this problem as an assignment, and I'll solve this problem in the next class. Okay, if you have any doubt, you can raise the question now. Otherwise, I will end the session. So those who have not chatted in their USN in the chat box, put your USN in the chat box. That will be considered for attendance. We have sufficient time. We can finish this problem by today itself. Okay, not an issue. So I will continue this problem. We'll just finish up this problem. We have 15 minutes more time to cover. Okay, just list out the given values. Radial load is given 1 kilonewton. Diameter of the journal is 50 mm, and the bearing diameter is 50.05 mm. Speed of the journal 15,000 divided by 60, converted to RPS. Albedo ratio is given, and clearance value you can calculate. It is 0.05 mm. Clearance ratio, that is 0.001. So C over D, that gives you diametrical clearance ratio. And referring to the table, SA 60 corresponds to an oil of H. And find out viscosity using the data handbook. It is 205 into 10 raised to minus 9 Newton second per mm square. So almost similar to the previous problem. So make use of the formula. Determine the coefficient of friction. Mu is equal to 2 pi square into neta n dash over p. So with the previous uh, problem solving experience, you can try this. I'll give you 5 minutes time to find out the power loss. Okay. So all of you just try this problem. I will give you 5 minutes time, and just post the answer in the chat box. Anyone who got the answer? 30.35.1 Newton. What is this?
Power loss, sir.
Power loss. It's coming 118.9 kilowatt. So probably you are telling the frictional force. 3034.9 Newton. Velocity is 39.25 meters per second. So put that value over here. So that gives you the power loss. How much quotient of friction? 3.06. Is it right? Quotient of friction? Okay, fine. So just try this problem from your end. So I will wind up today's class. So we will meet in the next class. Okay. So thank you one and all for your patient listening. So I'll sign up now. Sign out now. Thank you.